Hello.
Oh,
All right. Okay, so we're looking at the notes. We're trying to finish, and we're trying to be done with all of this stuff right here. So we got to make sure that we're paying attention to everyone. Okay. And everyone should be actually on track with what we're doing.
Get the blueberry.
Well,
I know, where's the blueberry?
It's under the
Oh, there was also blueberry flying into me too.
Wow.
I didn't even know.
I know you're like totally out of it.
What?
Can I see one?
All right, so right here, so now on these problems right here, it says using the washer method. I really need you to follow
I know,
this.
I know.
No, it's okay. Like I said, these problems are going to be the ones that you're going to see on the AP exam. You're not going to have just a regular revolution. You're going to have a revolution that is around a non-axis.
A revolution?
Yes, because we're going to take our function, we're going to revolve the function around something that is going to be parallel to one of my axes to be able to get a three-dimensional shape. So when I did the problem yesterday, remember we did a problem and we did it twice. We revolved it around the x-axis and then the y. And because when I revolved it around a different way, it gave me a different shape. And that shape, that object, has a different size. So my volume will be different. Yes? My volume would be different as it's rotating around that. Now right here it says the volume of a solid revolution generated by revolving the region bounded by the graphs. Now what does bounded by the graphs mean? Where they're intersecting, right? And and the line x equals 2. So we're going to go through, and what was the first thing I said yesterday to do? Graph it. Let's do that. So if I'm starting here, we have set those two equal to each other. 2x equals x squared. Move it over. 0 equals x squared minus 2x. X quantity, x minus 2 equals 0. Right? Okay, so now I'm going to have x equals 0 and x equals 2. So those are the places in which that they are going to intersect. That's intersecting on my x-axis, right? So I'm going to have a graph x squared, which is going to look like this, and 2x is going to look like this. So, and I have and 2. All right, so now my function, okay, I am also have the function x equals 2. So I'm going to draw a dotted line where x is equal to 2. That's going to be here. About the line. Now, the term about the line means that's what it's rotating around. So it's going to rotate around that. Now, that is a vertical line, right? Now, when I'm doing a vertical line, what is my equation going to have? Yeah, dy, right? So I'm going to have a dy. So I need it in terms of y now, right? So let's change up what I have here. So my functions are going to look like this. So I'm going to get x equals y over 2, and I get x equals y to the 1/2. Yes, okay. Yes? Because I take the square root of x squared, right? So I get that.
And now we need to add two rows of those and put them in tangent.
And so now my bounds are gonna be in terms of y now, right? So, let's plug these in. Let's plug my points, which was it was x equals 0 and x equals 2. So when I plug that in, I'm gonna have, what am I gonna get here? So if I plug in 0 for this, I get 0, right? So my bounds are gonna be 0. And when I plug in x equals 2, that's gonna give me 4.
What about height before?
Yeah, I'm gonna do that, but I'm setting up my problem. Because this is going to go up to 4 right here. Because it's gonna be in terms of dy now. Okay, so as I'm rotating this around here, so it's gonna look something like this. So it's rotating this way, so this is gonna be my three-dimensional shape. So my radius, okay, that's the reason why I wanted you guys to draw this all the time. My radius should start from where? It would start from 2, right? Okay, and it'd be 2 to what?
2, 0 or 2, 2, 4.
No, because remember the radius is going to change depending on the function, right? And because I only want the volume of the whole thing, right? Okay, so it's going to be the outside minus the inside. So the volume of the outside in this case would be what? Okay, you're getting close. Okay, so now you're getting close. A little bit less mumbling though. If you're gonna say it with confidence. So I'm gonna show here to here, right? Right there. That's gonna be my radius, right? So the radius of the outer function is going to be
1 over 2 plus 2 squared.
because I only want from here to here, right?
2 minus 5
So it's gonna be 2,
minus 1.
right? Because 2 would give me all the way from here.
Yeah.
Come on now. That's 2, right? But I only want from here to here. So it's going to be a 2 minus
Y over 2.
whatever this function is, right? Because the function is going to give me this piece. Does that make sense or no? No? Okay. Here's a better. So from here, we're rotating it around this way, right?
Yeah.
So we're rotating this way. The radius at any given point is going to be from here out to my outer line, right? The line in red. Okay, so since I'm doing it in terms of y, this point right here, it would be whatever this radius is from here to here. So that's 2, right? But I don't want all of 2.
Right.
So it's going to be a 2 minus whatever this is here. Right? And so how am I going to figure out whatever this is to that point right there? Just whatever my function is. So whatever the function is at this point. Okay, so now I'm going to do this again, but I'm going to put it right here at 1 because that's where I think it is. Anyway, so it would be 2, which is all of this, right? Minus, so for this one right here, if I say this is 1, right? That'd be 1. That means there's also 1 on this side, right? Yeah? So there'd be 1 on that side. So the whole thing would be that. So it's going to be 2 minus the, whatever the function is going this way.
And then
So-
we'll give you that.
Yeah, and that would give me of this. So 2 minus 1. So as I go up, my radius keeps getting smaller, right? And because my function keeps getting bigger, my function keeps going further out for my x values, right?
Yeah.
So I'm just going to keep subtracting whatever it is going this way all the way, like that. Is that better now? Okay, are we okay?
Yeah, yeah.
Okay. All right, so I had to go to the good drawing just because mine sucks. All right, so we now know what my function is going to be. So it'd be 2 minus my outer function, and my outer function was what?
Y over 2.
Y over 2, okay.
Right,
Close squared, right?
Yep.
And I'm missing,
minus, put in the minus,
okay, and then my minus my other function.
2 minus y.
Okay, same thing. It would be the same thing, but it's going to be to this line in here, to the 2 minus,
Y to the 1/2.
oh yeah, y, and all this here has to be dy. Now, I want you guys right now to do this math. Okay, we set it up. I want you guys to do the math, please. I'm gonna pause the video so it doesn't. All right, if you guys are working, keep working. I'm just gonna start my problem. Okay, I'm gonna do my algebra first. Okay. So those are gonna go away, and I'll just go with it. Negative y squared plus y3 over 12 plus y3 over 2, 8 over 3 minus y squared over 2 from 0 to 4.
Wait, where did you get minus y squared? What? Over 2.
What's the integration of negative y?
Yeah, but it's like negative. There's negative 2y.
I know, but I didn't combine them yet. I didn't combine them yet.
Oh, okay.
So if you do combine them, you get negative 3, right?
Yeah.
So it's negative 3, that would be negative y squared over 3. And if I combine these two, No, y squared over 2, 3y squared over, yeah, 3y squared over 2. Yeah, it's the same thing. I just didn't combine before I did that. Okay, you'll get the same. So let's see, pi bracket negative 16 minus 64 over 12 plus 64 over 3 minus 16 over 2. That's minus 0, which is my lower bound. Oh, crap. At least divided by 2.
Why do you have negative 64 over 12 if it's gonna be positive?
Where,
You know, because you plug in 4, it's gonna be just positive 64 over 12.
let me see. You're right, that should be a plus, sorry. There we go. All right,
And 64 over 12 is the same as 16 over 3, so you can add it.
16 over 3?
Yeah.
Okay, good. I didn't reduce it, so pi, you said 16 over 3 plus 64 over 3 minus, what's that over 3?
72 over 3.
Which is going to give me
80 minus 72, which is
89. You said 89?
No, 80.
80, thank you, yes, 80, so 8 pi over 3. Okay, hopefully everyone got that? Okay, yes. Okay, not too bad. Like I said, all of these right here, this is what you're gonna see on the AP exam, the big problems. So being able to do this from a non-axis is important. So the key step is to draw it, try to figure out where your radius is, and go from there. Okay, because I used to, whenever I did the problems myself, I would try and think about it and try to like come up with a formula for it. But if you draw it, it makes it so much easier just looking to see where is it, where's the radius at? How big is my radius? That's all I'm looking for. Because I try to add, subtract, or, you know, it just depends on where it's at, so. All right, makes sense? Like, share, and subscribe.